Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Faradullah for Telkom University Purwokerto, Indonesia. Today, I am honored to present our research title, Recommendation for Veneer Inventory Control Using Demand Forecasting and Min-Max Methods. This research focuses on improving inventory control for veneer materials in a plywood manufacturing company, aiming to balance supply and demand effectively. Okay, to make this research easier to understand, I structured the paper following the writing format, which consists of four main sections. First, the introduction, explaining the background, problems, and objectives. Second, the theoretical review, which outlines the research methodology, which outlines the relevant literature and conceptual foundation. Third, the result and discussion, presenting data analysis and propose solution. And finally, the conclusion, which summarizes the key findings and recommendation. Let us begin with the background of this study. The manufacturing sector contributes more than 19% of Indonesia's GDP, making it a major driver of economic growth. However, efficiency and raw material control remain persistent challenges. In one of the plywood manufacturing companies in Banyumas, one of the main issues is the frequent shortage of veneer, a thin wood layer that is essential for plywood production. This shortage often causes production stoppage, shipment delays, and decreased customer satisfaction. From the data collected, veneer stock out occur even when plywood demand remains high and fluctuating. The graph of demand, production, and unmet demand over the past 3 years clearly show a gap between production capacity and material availability. This condition highlights the need for a more structured and measurable inventory control system. Okay, this graph illustrates the demand, production, and unmet demand of period from August 2022 to July 2025 based on actual company data. The objective of this study are twofold. First, to understand and analyze the current veneer inventory control system implemented by the company. Second, to identify the cause of inefficiencies and propose improvements that can enhance the effectiveness and efficiency of veneer inventory control. Here is an overview of the study. This research aims to propose a veneer inventory control system using demand forecasting and the min-max method to address stock shortage issues at company. The min-max method is simple, easy to implement, and proven effective in maintaining raw material balance and supported by previous studies. Historical data on veneer usage and purchasing were analyzed to determine the optimal minimum stock, maximum stock, safety stock, and reorder point levels. Before presenting the result, let me briefly describe the research methodology. The study used both primary and secondary data analyzed with Pumpkin and software. For forecasting method were tested and the most accurate on was selected based on error values. Inventory control was designed to balance stock and cost with an average lead time of 3 days. Finally, the min-max method was applied to determine optimal stock level that ensured material availability and cost efficiency. This slide shows the main stage of the min-max method applied in the study. It begins with data collection and demand forecasting, followed by determining the lead time, calculating safety stock, minimum and maximum stock level, reorder point, order quantity, and finally order frequency. Okay, the graph in this slide indicates a horizontal demand pattern, meaning that demand remains relatively stable over time. Therefore, for forecasting method were tested naive method, moving average method, weighting moving average, and exponential smoothing method. At the forecasting stage, the method was selected based on the lowest error value. As a result, the moving average method was chosen as if achieving the lowest error rate of 5.64%. Okay, this represents the results of the demand forecasting process. The projected demand values were obtained using the moving average method, which provided the most accurate and consistent results for Veneer consumption prediction. Based on the forecasting result, the total veneer requirement was calculated. Each unit of plywood requires 12 sheets of veneer, so the projected veneer demand was multiplied accordingly to estimate total material needs. The final calculation results are shown here. The maximum filler capacity is set at 161,276 units, the minimum at 81,233 units, with a safety stock of 1,189 units, and the economic order quantity or AOQ is 160,087 units, and the reorder point is 81,223 units, and the order frequency in year continuous production and efficient inventory turnover. In conclusion, based on the Banyumas, several key findings can be drawn. Veneer inventory management remains inefficient due to the absence of standardized control mechanism. The integration of demand forecasting with the min-max method successfully optimized safety stock 1,189 units, minimum stock 81,233 units, maximum stock 161,276 units, and the system achieves 60 replenishment cycles per year, balancing stock availability and cost efficiency. There will be supporting continuous production and enhancing supply chain performance. Okay, that concludes my presentation. I would like to express my sincere gratitude on my supervisor, my institution, and private company for their support throughout this research. Thank you very much for your kind attention. I will be pleased to answer any question after the video session. Thank you.